Alright, we have a final Fourier series example. Well, normal Fourier series. Next we're going to look at a quick little half-range expansion example. Because I believe it is going to come up when we're looking through all of our solutions later on. So I do want to do half-range expansions after this. Do like one example. But here's our last normal example. Oh, I forgot to erase all this. Well, that's fine. You get the idea here. We have from -2 to 2, just like the last one, except we only have one function instead of two. It's not piecewise. Period is 4, length is 2. See, if we graph this, we know what x squared over 2 looks like. Right? Sorry. We have x squared over 2. That's what the graph looks like. I did it for 2 periods, not 3. This is what it looks like for 2. Now we just have to find the Fourier series. Hold on a minute. I just want to copy over these. We get a clean copy. Sorry. Erase these. Okay. For this problem, what kind of symmetry do we have? I see symmetry over the y-axis, which is, what kind of symmetry is that? That's odd symmetry, right? No, even symmetry over the y-axis, right? Even symmetry. So we have a Fourier cosine series. How do I know this? Well, I can tell you right now, we at least know that b sub n is going to be 0. We know that that's going to be 0 for sure. But let's take a look at all of them though real quick. We're integrating an even function. So this is going to be something, because it's even. A sub n. This is even. This is even. That's an even function that we're integrating. That will give us something. But b sub n, this is even. This is odd. Those multiply and makes an odd function. That is 0. Excuse me. So, a sub naught. What's our period? Sorry, our length is 2. Oh, this problem's so nice. I only have one integral instead of 2. Okay, x squared over 2. Oh, that's so nice. That's a nice break from those piecewise ones. Okay, this will be x cubed over 6. That would be, what's 2 cubed? 8 over 6 minus same exact thing. Is it 0? There's no way. Wait a minute. Wait a minute. Wait a minute. Apparently, that doesn't make any sense. Oh, wait. It's negative. Hold on. Yes. Basically, here. This is what I'll do. Just integrate it over half of it. If you look at it here, this is the same area as this. So just multiply it by 2. Go from one range. Do half the range. So that's literally just x cubed over 6 from 0 to 2, which is just 8 over 6, which is 4/3. Let's look at, what else do we need? A sub n. Let's do the same thing. We're going to do the same thing over half the range. This is cosine. 2 of pi nx. N pi x over 2. Oh, man. Oh, man. I see 2 integration by parts in our future. Oh, man. I thought this was going to be easy. I mean, it still isn't too bad. It's probably easy. And of course, it's cosine. If this was b sub n, it would be easier, though, than a sub n. Excuse me. dv. 2. V is 2 over n pi sine n pi x over L 2. Yes, I agree. So we have UV minus integral V du. I'm going to pull this out. Dx. Okay. Wait. Oh, I've made a grave mistake. I have made a grave mistake. I hope you guys noticed it. I'm gonna fix my mistake here. Whoops. I think that's correct now. Oh no, it's UV, so that's x squared L. Yeah, okay. 0 to 2. Let me make sure that's good. Yeah, okay, that looks good. So we should have an x there. Yeah, because it's 2x, so it's before. And that's an x. Yeah, okay. Okay. It's all fixed up now. Times 2, so that's 0. What am I doing? The whole term's 0. You know why? Because I saw the vision of that. Okay. Just like the last 4 examples. Okay. This is what we're left with over here. Man. Except this is actually... Okay, now I'm doing this one correct, right? This would be negative. That's supposed to be a 2. Okay. UV oh, this one's nice. This is not too bad. Because this part right here, if you didn't see already, is 0 because of this. After you integrate, okay. So now we're left with this right here. We can distribute that in. This becomes zero, plug in 0, that's just 0. Okay. Oh wow, look at that. What are the chances that's right? Let me check. It's almost right. Apparently, we're off by a factor of 2. How did that happen? How did that happen? The 1/2 on the outside. Did I forget the 1/2 when I did it? Okay, so it turns out my notes were very wrong. I am correct here, as a matter of fact. So, thank God, right? It is in fact 8 over n squared pi squared times -1 to the n. And this is it, right? We're to write out our solution. A sub naught over 2. A sub naught was 4 over 3 over 2. That's what, 4 over 6? Which is 2/3. Okay, n equals 1 to infinity. We can pull out. And then we're just left with this. Let me just double check that. Yep, that is correct. That's about as simplified as it gets. That was a pretty simple one, right? Whoops. Alrighty, that's the end of these examples. Of course, if you're wondering, yes, there is definitely harder examples out there where you gotta use trig identities and whatnot. But we may have to worry about that in our later problems anyways, because we're not done with Fourier series. We still have to actually solve PDEs. So don't think we're out of the clear yet for these. And I do want to do one video on half-range expansions because that's also important. I think it'll come up when we're doing PDEs, actual problems. So I want to do that quick and then we'll start our PDEs. So see you in the next one.